Hello learners, how are you? I hope you're having a good time. So once again, I'm here for your help. And today we are going to discuss unomials and polynomials. And our final topic is radical number. So in these two topics, we'll focus on, and it will be at most 30 minutes. So this is going to be our T and T series 4. That means tips and tricks series 4. And I will try to address some basics or conceptual knowledge so that you can be beneficial. And the topic is too easy, especially it's fits for I believe all of you learned it from high school. So let's recall again, because for TOLC-E or even for TOLC-I, sometimes you need to solve some mathematical problems without calculator. So even though it's easy or from schools, but still you need to learn them. And furthermore, I would say radical number operation is very important for all. So let's start with unomials and polynomials. What is unomials? Unomials, when an expression like 12x square y cube z, this is an expression, this is called unomials. But if we add two unomials together, if we add two unomials by summation or by subtraction, like algebraic operation, then it becomes polynomials. For example, 12x square y cube z, and another unomials 13x square 7y, not 7, I can write y. So in these three unomials, we can make polynomials as well if we just plus it. So first is unomials because this is not added or subtracted from any other unomials, therefore it's unomials, a single term. It has numeric term and letteric term. That means a part which represents number 12 and a part which is composed by variables. It could be x, y, or even a, b, c, m, d, whatever. Like we can write another one, half x square b, or negative 3 ab cube, all are unomials. So what is the degree of unomials? In particular, for this case, if you are looking for degree, then you have to sum all of the power of variables. So here we can see x has power 2, y has power 3, z has power 1. So total power is 3, 2, and 1, 6. So power, degree or grade of unomials 12x square y cube z is 6. How about this case? A has power 1, B has power 3. If we just sum them, it will give us 4. So this is the power of unomials, minus 1 by 3 AB cube. Now, if we would like to find out the degree of polynomial of this expression, 12x square y cube z, 13x square y, in this particular case, what would be the degree of these polynomials? Remember, to find out degree of polynomials, we have to find out degree of all unomials inside that polynomials. I can extend it minus 1 by 3 AB cube, let's say, or minus 4 this way. So for make it more good looking, I'm writing xy cube. Now let's find out. This has a degree of 6. This term degree has a degree of 3. This term has a degree of 4. And this term degree, do you know what is the degree of this term? 4. Okay, just consider x has power 0, and we know if something power is 0, which is 1, so it doesn't affect, right? So there is x, but its power is 0, so our degree is 0 for this particular term. Now we can evaluate which term has maximum degree. This term, so 6 is called the degree of this polynomial expression. Okay, and this term is called leading term. What is the leading coefficient then? 12 is the leading coefficient. I hope you understood about unomials and polynomials. Those are simples, but sometimes in exam they make some complex problem, like they'll write equation like this: x square y cube 2x6 plus 3x square equal to 0. I have written an equation. However, let's consider only polynomials. So what would be the degree of these polynomials? So, you know, like here is 2, 3, 5, and here is -6. So if you sum them, the dominant would be 6. As dominant is 6, so the outcome would be -6, -3, no, -1, sorry, -1, and this will give us a degree of 2. Therefore, in this particular polynomials, our degree of these polynomials is 2. Okay, so that is the answer. Okay, so let's do some summation or subtraction, like operation with uninomials. So if you look here, this lettering term are the same: a square, a b squared c, a b squared c. Only difference in numeric term or coefficient. So in these particular cases, you can consider this whole unit as a one object, which is x, and this whole unit also a single object, x, right? So 7x plus 3x. So if you sum, what would be the answer? 10x, right? Yes. So 10 a b square c. Remember, if polynomials are the similar, or except the numeric term, the lettering term are the same, in that case you will always get a polynomial, I mean uninomial. But if they are not same, let's say 7ab squared c plus 3a squared bc. In this particular case, we can see here this lettering term ab squared c and a squared bc are not the same, so we can't sum them. Okay, we can't sum 7x plus 7y. It's not possible. It would be possible if there would be 7x. So the same, this is a symbol, this is different from this assembly of alphabet. So what we can do, just remain like this, and we can find a conclusion out of these. When uninomials are different, their summation will give us polynomials. Okay, furthermore, we can do one thing we can do, that is taking common. Here we can see for all cases a b c are present, at least one a, one b, one c, so we can common them. So if I call a b c, okay, I can call all of them, then the remaining part is 7. First there was a 2b b square, so 1b will remain, plus 3 1a will remain. Okay, so this is the simplified version of what we can do, but still it's a polynomials. Okay, now let's do some operation like product, division, and power. So we'll do some product like 3x square y cube z multiply 6x y square z square. Okay, so you have to multiply these two uninomials. So in this case, first of all, we have to multiply the numeric term 3 and 6. So it gives us 18. Then one by one we'll look. Here the x square and here the x. So we'll write x and we'll add their power, like x square, like from first uninomials gives us power 2, x from second uninomials gives us power 1, so we'll just sum them, dot. Now we'll consider y has 3 initially, and then at second uninomials it has 2, z 1 plus 2. So our answer is 18x cube y 5 z 3. So this looks like simple, right? Very simple. But you know, when they make questions, like we can consider these questions in TOLC-I or TOLC-E, and there are 5 options. So 5 options are always critical and very close. They won't be straightforward like this: 8x cube y 5 z cube. No, I cannot grant they would be simply like this, because this term, this answer can be explained or can be simplified further. For example, if I write 18 x cube y 5 and then z inverse, is it not same? Yes, it's same, because z inverse 3 means actually z cube. Similarly, we can write this expression in another way, like 18 x cube okay, not x cube, y 5. As x and z has same power, what we can do is x and z we can group together at the bottom, and we can make a whole power of 3. See, so these options, this option, all are correct. So in real-time exam, you will be given very similar options and critical. Don't expect that it would be exactly same as you expected. No, you have to be careful. You have to look on the options, and if you need any adjustment, then you have to do that. Otherwise you can't find the answer. Okay, so until now I have done only operation with uninomials, but what about polynomials? Let's say 2x square plus 3xy plus 1 multiplied by 2x plus 1. So in this situation we have to multiply whatever you think, like let's say we have to multiply this whole term by this one, right? So that means we have to multiply first by this 2x by the whole term, then once again by the one whole term, then we'll calculate. So this is the standard way. I believe you studied this in your schools, but I can show you one more time. For example, first let's do it by 2x. So 2x and 2x square plus 2x 3xy, I'm writing this way, plus 2x. Now I will write this plus again by 1 all term we have to multiply 2x square plus 3xy plus 1. So as I didn't write bracket for all, so let's put a point here. Now further you can calculate how much it is. 4x cube plus 6x square y plus 2x plus 2x square plus 3xy plus 1. Now we cannot find any common term, therefore this is the answer. Okay, yes. So remember, in real exam you have to use several formula. For example, a square minus b square formula. A square minus b square equal to a plus b into a minus b, a plus b whole square formula, a plus a square plus 2ab plus b square. I can write this way, a plus minus b, then I can just put a minus here, you will understand. So this kind of formula is very important, and you need to learn how to factorize, how to simplify it, and how to remove from both sides. In future classes, when I will teach about equation, I will talk about those in details. You will learn. Similarly, if you want to multiply 3x square plus 2x square plus 1, 2x plus 3. Oh, we did multiply already. That was the multiplication. If we want to plus this, like addition, not multiplication, addition, in that case we have to just simply add them with these polynomials. That as simple as it. And if we look for common terms. If some terms are same, then we can add them. For example, it's better to write here this way. Let's see here, 3x square, we cannot modify it, but we can see here 2x and here also a 2x, so we can write 4x plus 1 and 3, 4. So this is our answer. So okay guys, and I think until now you understood. In this page I explained the multiplication of two polynomials, and then I explained addition of two polynomials. Also I wrote down 3 formulas that's important, it may need in your real exam, so memorize them. Now we'll talk about radical number operation. Radical number. So radical number is a number that okay, this is a radical number. Okay, nth root of a, we can write cubic root of 8. This is a radical number. Cubic root of 5. Whenever a number is expressed by root, it's a radical number. So two terms here. Number one is a and number two is n. So depending on this n and a, the root of this square would vary. Like if we know the properties of n and a before, then we can guess, we can predict what kind of root we'll get. So I will discuss in details, but let's do some practice. Square root of 4 we know 2. Is that right? Most of you, I think all of you, isn't right that square root of 4 equal to 2, because we have to put positive and negative sign. Why? Because we can get 4 two different ways. Plus 2 whole square will give us 4. Minus 2 whole square also will give us 4. So if we square root of 4, then we have to consider both situation, plus 2 and minus 2. Therefore, we cannot simply say 2. But however, in some problem, if it is written like that, absolute of square root of 4, it means what? Let's simplify. This absolute means only value. Absolute doesn't consider sign, whether it's negative or positive, only value. So plus minus 2 will give us simply the value, if the value it's holding, so that is 2. Now let's discuss about some properties. As I already wrote, n root a. So when n is greater than 0, when a is greater than 0, n is even. N is even and a greater than 0. In this situation, we will always get 2 root. Okay, 2 root but opposite signs. For example, let's do it. 4, it will give us plus minus 2. 16, plus minus 2. For each cases we have here is 4. Each cases will get 2 roots but sign is opposite. We can have a square root of 5. It will give us plus square root 5 minus square root 5. Always 2 square roots but opposite sign. If a greater than 0, n is a odd number. In this particular case, we'll get only 1 root. Cubic root of 8, 2. Okay, if a less than 0, n is even number. 2 square root of negative 4. So negative 4, square root of negative 4, we know it will not give us a real number. It's a complex number, or you can say non-real number. So in this particular case, we'll not get the root, but yes, if you consider the complex area, then yes, you will get a root there. A less than 0, n equal to odd. In this case, again we'll get root. Let's say minus 27. Okay, so this gives us minus 3. So I hope you understood, when the a value is negative but the n is odd number, positive and odd number, then we'll get a root, and that is negative always. So this was the basic properties, and we can simply simplify. Minus 27 can be written like minus 3 power 3 square root of 3. So square root of 3 and 3 cancel, so minus 3 remains. That's the answer. Now let's learn some shortcuts of radical operation. Let's say n square root of a power m, we can write it square root of np mp. Okay, so this is a formula you can memorize. Another formula, n square root of am, we can write n power n divided by p, m divided by p. This is second formula. So how it makes sense, like, you know, if it's like, take a look here, here is n and m. What we did, we just multiply a extra factor p as a power of a and with n. So if we can do that, if we can multiply this way, this will not change the total or ultimate results. So remember, we can do that. Let's say square root of 3 power 27. Okay, not 27, I can write any number. Let's say 10. I think a number should be like this, 25. So we can definitely write 3 into 2 square root of 25 power 2. It's okay. The overall the value of this term won't change if you change it this way. This is the concepts of this formula. So we can write 6 and 5 square 5 to the power 4 this way. Okay, let's do a problem, mathematical problem on this, then it would be clear. Let's write 6 root 27 a 9b6. Okay, we will simplify this problem. So how we can do that? We have 6 here, and inside of root we can write 27 as 3 power 3. It gives us 27. A we can write 3 power 3. B we can write 3 power 3 multiply 2. I'm sorry. So we can write 6 3 a cube b a square whole power cube, right? It's possible. Now here we have 3. What if this term can be simplified into 3 by 2? 3, not 3 by 2, but 3 multiply 2. Okay, 3 multiply 2, and inside 3a cube b square whole cube. Now what we can do is this 3 common term, and here the power common term we can cancel out according to our formula, the first formula. Okay, we can write this way: the common term we can cancel out or take out from power of inside value, and here from here p we can cancel them out. So now our results become square root 3a cube b square. This is our answer, and as we know, we don't need to write 2 because square root already means 2, so we don't need to write it again. This is our answer. Again, I'm saying you may think in practical exam you will, in the option there will be like this, but not. This can be simplified in different way, many way. It can be simplified this way: 3a cube b square. We can write half simply, right? Square root means half power. Or we can write 3 half a 3 by 2 b, 2 by 2 means cancel each other. So this is also correct expression. Then what else? We can write what more way? Let me think. We can write 3 root 3 root a cube b. So this way also possible. Further, we can write root 3 b divided by a minus 3 by 2. So the same mathematics I can express different way. So I would suggest you, whenever you are sure that this is correct but still you should look other options, because finding out the right options is tricky. Sometimes the problem statement is very easy and you can simplify it easily, but what they will do, they will modify it complex way or such a way that all options look similar. These options also can be simplified this way, like b root a power cube, and the root 3 we can write this way. If we multiply root 3 both side, then it becomes 3, and at bottom becomes root 3. So this is another expression. So I would suggest to practice as much as you can. Here is another formula. I would suggest you to study it, memorize it. Like when nth root are the same, but the base or the value inside the root are not, in that case you can write this way: equation square nth root of ab. Let's have an example. Root 5, it's a very simple example. Root 5, we can write root 25. 5 into 5, 25. Or if you want to further simplify, then it will give us 5 square, so 5. This is the answer. Yes. What if we are given a complex form AB square, then A square BZ. So in that case, similarly, as our value n is same, so we can obviously write that AB square dot A square BZ. Okay, now we can further simplify. A have 3 times, B also 3 times, and Z. This is our final answer. Opposite way you can write, like using that same formula you can apply here, like square root of A cube B cube dot square root of Z. This is the same. Just consider this formula is the same. We change the expression. This is another tricks or formula, whatever you say, where nth root of A whole power m equal to nth root of A power m. So in this particular formula is insightful, like you can just put this m inside the root. It won't change the value of whole term, so it's completely okay. Now let's solve this problem. Fourth root of 4 whole cube. So in this case we can write 4 whole cube, which will give us 64, and this 64 we can write 8 square, right? So now we can apply our first formula, where we discussed that if common term from outside of the root and inside of the root are common, then we can cancel them out. So I am calling them 2 into 2, 8 power 2, so 1 2, and here we can cancel them. Remains a square root of 8. This square root of 8 can be further simplified. How? 4 into 2 equal to 8. Therefore 4, if we take it out of the square root, then it becomes 2. So 2 root 2 is our answer. Most probably this is our last formula, and by this formula we'll stop today. So here you can see nth root of nth root A equal to m dot n square nth root A, that can be written. So this is the expression. Now let's have a problem, then we'll understand. Let's say cube x x y square z. Okay, we have to simplify this problem. Now let's compare with the formula. In the formula it's given that square root nth root of something, nth root of A. Here A equal to this unomials x y square z, but we can see in between these first two root there are another value, which is x. So we cannot directly apply the formula for this case, because this space must be empty. So this x just outside of this square root, so we can take him inside. or we can take him outside, but it's better to take him inside than outside, because directly we can apply the formula and that makes sense. So remember, x has power 1, right? And this is a square root. So if I want to take it inside, what should be the power? X square, because if there is a s, okay, let me write here 3 x square x y squared z. Now here, this x square, how I write this? I simply insert this x inside our lowest square root. So as it was square root, we put square because it's the same. If you want to take it out again, it will become x. Now we can simplify further. If we want cube, here x square, we have one more x, it becomes x cube, y square, z. So this is our answer. So some brilliant student or very curious, if they wanna do further, yes, further also possible. You can write cube root of x cube, cube root of y squared z, and you can say x cube root of y squared z. Yeah, this is also correct answer. So dear friends, I hope you enjoyed. I tried my best to give you something today. Initially I also wanted to talk about expression like equation and inequalities, but because of time constraint, I couldn't do that. But in future, in my next lecture, I will do that. So practice as much as you can from the materials I provided, from the CISIA practice materials or from the free materials I gave you from the book, so you can have good preparation for the exams. At the end, I would suggest you to share with your friends, and if you like it, definitely make a click on like button, and if you didn't subscribe me for future updates. I'm extremely busy, so that I couldn't post regularly, but yes, I tried my best. I wrote a book, and after writing book is not easy, so there are a lot of technical challenges and problem generations, proofreading, a lot of work, but I successfully I have done that. Grateful to Almighty, and you helped me a lot. I also sending the book for free. If you want to get the free version of my book for free, you can complete the survey. You can check the post section of my YouTube channel. You will find a survey. Complete the survey. I will send you a free version of my book, and you can practice at least 150 problems. More than 100 problems are free, so you can practice them. And I know there are a lot of difficulties because some students do not have MasterCard or PayPals. Therefore, it's really hard for them buy the book, and Google Playbook. Google Playbook doesn't operate most of the countries, only 66 countries, and including India, Turkey, and all European Union, Middle East. But still some countries where millions are living, like in Pakistan, Bangladesh, and some other Asian countries, African countries, you can't buy a book from Google Play Books. I hope Google Play Books will improve or start business outside these 66 countries, and that would be helpful for you to download. And I'm keeping update of the books so that you can get updated information of new problems and explanation. Already I added new explanations for all problems. That would be really helpful for you. So if you have any queries, any questions or anything, just let me know by mailing this email address, tolcprephub@gmail.com. I hope you enjoyed, have a good time, and have a best preparation for your exam.